In part one of our introduction to trigonometry, we talked about the definition of an angle, and we talked about a couple of types of angles or terminology about angles that are important for trigonometry. In particular, we talked about angles that are considered to be in standard position, which meant the initial side is attached to the positive x-axis in a coordinate plane, and the terminal side can rotate either positive direction, which would be considered counterclockwise, or negative direction, which would be clockwise. So the size of an angle in the trigonometric setting isn't limited to 180 degrees or less as it is in a geometric setting. We also talked about coterminal angles, two angles that end in exactly the same place in the plane in rotation. Now we want to talk about the degree unit of measure for angles and some types of angles associated with the degree, at least as most of you have been exposed to them in your earlier math classes. So let me ask you first, you're probably familiar with the degree, but do you know its definition? Well, just in case the answer to that is no, here we have the definition of a circle. You can see that it's defined as being a central angle of a circle, which means nothing more than the vertex of the angle is at the center of the circle, and it's an angle that has a rotation that's equivalent to 1/360th of a circle. And let me show you a picture of that. Here's a picture of a 1-degree angle. And we could say that this 1-degree angle cuts an arc right there from the circle, or subtends an arc. That's 1/360th of the length of the total circle or its circumference. Now let me ask you this. Where did 360 come from? And your reaction initially is, well, it's a circle, duh. That's true, but why is it that a circle is said to have 360 degrees? Where did that come from? I'd like to encourage you to ask yourself those kinds of questions, because often where things come from holds a little nugget of information that is conceptual and enables you to apply things in different settings that you wouldn't be able to if you didn't have that knowledge. This isn't particularly one of those, but it is a tie to a very, very, very ancient civilization, and from that perspective, it to me makes it interesting. And over the years, looking up questions like these myself has enhanced my connection with mathematics and also enhanced my enjoyment. And so I'd encourage you to use your fast Googling skills and look at things like that. Now, there are a list of angles, various names that are associated particularly with degrees. However, there's one particular type of set of angles that I'm going to give you a definition for that isn't directly related to degrees. It's a pair of angles that are important because you're going to see this word often in a mathematical setting where you're dealing with diagrams and circles and those kinds of things. And it's the word adjacent angles in particular. Now, what are adjacent angles? Well, what does that underlined word adjacent mean? You'll hear things like two adjacent buildings, or two students even who are adjacent. What does that mean? The word adjacent means side by side. And I would say that's what adjacent means in our everyday English language applications. Like most of those definitions for basic English uses, the mathematical definition is a bit more precise. The mathematical one wants to convey the idea of not just two angles that are side by side, because that could be interpreted a number of different ways, but they're so close that the side between them is actually merged into a single side. So you have a picture here of two angles. Let's call them angle 1 and angle 2. That would be considered adjacent angles. So the definition says that it's a pair of angles, exactly two angles, that share a common side between them. So it's like two people side by side leaning against each other, so that their two arms become like one arm between them, so to speak. Now let me show you the list of angles and definitions that you need to know. And again, most of these are things that you've heard for years, but we take the time to remind you of them at the beginning of a course in which they're going to be important again. And these are definitely going to be important because they're part of the language of mathematics, and you'll encounter them frequently in the trig setting. And let me erase this little bit of artwork here because it's not very attractive. There you go. These are the particular definitions that you really need to know. I hate to say memorize, because when we memorize things, we tend to cram it in for short term, and we really want long-term usable information in our storage banks. So we really need to learn what they are, and a lot of times if you picture them or understand what the words associated with the name mean, it becomes easier to have long-term memory. So adjacent angles, I just showed you a picture. Acute, that word means sharp or sudden, and so acute angles should be kind of sharp and sudden, and that's in terms of degrees what an acute angle is going to look like. So it's got a particular range of suddenness or sharpness before we change its label. Notice that it can't be equal to 0, can't be equal to 90 degrees. It's just anything in between. Once it gets to 90 degrees, it's called a right angle, and we usually indicate it in a diagram with a little box in the corner. Now, why is that thing called a right angle? Is that right as opposed to left, or right as opposed to wrong? Another thing you ought to Google just for curiosity's sake. Okay, an obtuse angle, if it's not sharp, then it's kind of longer and drawn out, and based on its measure there, you see that it's anything that's larger than 90 but not quite 180, because that 180, the straight angle, would be just as it says, a straight angle. Now, why do we bother to look at something like this and say it's an angle, because angle in our minds tends to look like something that has a corner. Well, if we go back to the thought that a circle has 360 degrees, then if we start measuring as we would in a standard position angle from the positive x-axis with the terminal sides anywhere else around the circle, if it goes from 0 degrees where both sides are on each other as if you were just beginning, similar to a clock at 12 o'clock, then to get to 360 degrees, which means to go all the way around, there has to come a point in there at which you have 180 degrees, and it turns out that it's exactly opposite the initial side, so it's just a straight line, so to speak. So you get a straight angle that's 180 degrees. Now the next two definitions are important, again language-wise, and are things that you're probably familiar with, but just in case. Complementary angles in words would be defined as a pair of angles, not just a bunch of angles that add up to 90 degrees, but exactly two angles that add up to 90 degrees, that have a sum of 90 degrees. Okay, so one of the mental images we have is take this right angle here and split it into a pair of adjacent angles, and there we have a pair of complementary angles, which is true. If we take a right angle and split it into two adjacent angles, the sum of them is going to be 90 degrees. There's no way around that. However, notice that it says here whether angle A and angle B are adjacent or not. So it could be any two angles in a diagram regardless of their position, but their measures add up to 90 degrees. Same thing with supplementary angles. It's true that supplementary angles, if they're adjacent, will form a straight angle, 180 degrees. But again, it doesn't matter whether the angles are next to each other or not. Just any two angles in a diagram or any two angles in a situation you're discussing that have a sum of 180 degrees. And so here are some examples. You've got a 30 degree angle as an acute angle, 150 degrees is obtuse, and because the sum of those two angles is 180, then you have a pair of supplementary angles. Or more generally, if x is an acute angle, then we know it's between 0 and 90, and therefore can have a complement. Well, we can find the complement by just subtracting x from 90 degrees. Or we could find its supplement by subtracting x from 180 degrees. And notice that an obtuse angle doesn't have a complement. It's already more than 90 degrees, but it will have a supplement. So learn this language that pertains to angles, and there you have part 2 of our introduction to trig.